So now, let's let B prime be this basis. Now that's script B prime, that stands for the basis. I'm using B prime for the matrix. Now your book uses P's for these matrices, but it doesn't use any notation for this one. So I'm going to use the B prime and the B, but not script B. Script B is going to stand for the basis, and B is going to be the matrix that you get from that basis, as we did previously. So there's the basis, and that basis, there's the matrix consisting of the columns vectors corresponding to the basis vectors. Then a coordinate representation of any x, which is just x1, x2, x3, that's just three numbers in R3, relative to B prime would be, I think I left a prime off here. Be B prime inverse of this matrix times the x vector is going to give you the representation in terms of B prime, just as with the B basis and the B matrix in the preceding. So totally analogous. So that x equals this, and that is also the same as the x B prime. Doesn't have the same numbers, but it's the same vector. The vector x, this vector here, expressed with respect to B prime, and it's also equal to the x vector as expressed with different numbers relative to the basis B. And this says then that if we multiply B by the x B prime, well, from this, if we do the, and I probably should have written out, I didn't. This is just inverse to the relationship that B prime x B prime equals x. Okay? In any case, it immediately follows that B prime times x B prime equals this, and B times the XB, the B matrix times the XB representation will equal this. Okay, so these are equal, and that follows that I think they're both equal to the x1, x2, x3, the vector according to the standard basis. And if we just take this, it's then obvious that XB prime equals B prime inverse times B times XB. Okay? Now, this matrix, this B prime inverse B, I'd call the P matrix, because I wasn't thinking ahead to similarity transformations and stuff. Should have been. Okay? And that's how I went on over here. According to your book's notation and the notation that's going to be consistent with the way we use similarity matrices to commutative diagrams and so forth, I should have used P inverse here, which means I'm going to have to use P inverse over here. Okay. Now I'm going to do a little addendum at the end where I correct this. But this should be P inverse, this should be P inverse. And that was the confusion that I couldn't get through at the end of class. I wanted to call it P. So I'm going to keep it as P here so I can correct it in a little addendum.